January 29, 1944. Somewhere over the Rhineland, 22,000 feet. The sky at altitude possesses a particular quality of silence that seems to amplify rather than muffle the mechanical sounds of aircraft engines, a paradox that Oberleutnant Werner Schröder of Jagdgeschwader 26 has never fully understood but has learned to interpret with the precision of a musician reading sheet music. On this crystalline winter morning with visibility stretching to the horizon and contrails marking every aircraft like chalk lines on a blackboard, Schröder hears something that triggers recognition before conscious thought. The distinctive, deep-throated roar of Pratt & Whitney R2800 radial engines, multiple contacts approaching from the west at his altitude. He banks his Focke-Wulf 190 toward the sound and feels his chest tighten, with a sensation that 18 months of combat have taught him to recognize as the body's involuntary preparation for violence against an opponent who possesses advantages that courage cannot overcome. Emerging from the sun's glare like mechanical angels of judgment come 6 Republic P-47 Thunderbolts in Finger 4 formation, their massive fuselages gleaming in the high-altitude sunlight. 8 50 caliber machine guns per aircraft pointing forward, with the inevitability of divine wrath. In that instant, Werner Schröder understands what bomber crews have known for months. The Thunderbolt has transformed the European sky from hunting ground into battleground, and German fighters are no longer the hunters. The Luftwaffe entered 1943 with tactical doctrines forged through 4 years of aerial combat that had established German fighter pilots as the most experienced and lethal in the world. Their Messerschmitt Bf-109s and Focke-Wulf 190s represented the cutting edge of fighter design, nimble, well-armed, and flown by veterans who had survived the Battle of Britain, the Eastern Front, and the escalating daylight bombing campaign over occupied Europe. The defensive strategy was sound and proven through hundreds of engagements. Intercept American bomber formations during their penetration flights, exploit the bombers' lack of long-range fighter escort by attacking beyond the limited range of P-38 Lightnings and P-51 Mustangs, destroy as many B-17s and B-24s as possible before they reach their targets, and withdraw before fuel exhaustion forced risky emergency landings. The intelligence assessments of American fighter capabilities reinforced German confidence. The P-38 Lightning, while possessing good range, suffered mechanical problems in the extreme cold of high-altitude European combat, and lacked the maneuverability necessary to dogfight Bf-109s effectively. The P-51 Mustang had not yet appeared in significant numbers. American escort fighters were therefore dismissed as limited threats, capable of defending themselves but unable to challenge German fighters for air superiority over occupied territory. The psychological equation favored the Luftwaffe: experienced pilots, superior aircraft, combat over friendly territory with the ability to recover damaged planes and rescued pilots. American bombers would continue to suffer unsustainable losses, and eventually, the daylight bombing campaign would collapse under its own casualty rates. Then the Thunderbolts arrived in operational numbers, and every assumption embedded in Luftwaffe tactical doctrine began to fracture. The Republic P-47 was unlike any fighter aircraft German pilots had encountered. Massive where European fighters were compact, brutally powerful where conventional designs emphasized efficiency, and possessing survivability characteristics that seemed to violate fundamental principles of aerial combat. The aircraft weighed 7 tons empty, nearly double the weight of a Bf-109, and was powered by an 18-cylinder radial engine producing 2,000 horsepower that drove it to speeds exceeding 400 miles per hour at altitude. But weight and power were merely statistics. The reality German pilots encountered was far more psychologically devastating. A fighter that absorbed damage that would destroy any Luftwaffe aircraft and continued fighting, that dove at speeds making interception impossible, and that carried firepower sufficient to disintegrate German fighters with single burst. The first major confrontations shattered German assumptions with the methodical inevitability of industrial machinery demolishing handcraft. The Thunderbolt's combat debut over Europe in early 1943 had been tentative, with American pilots learning the aircraft's capabilities while German pilots cataloged what they perceived as exploitable weaknesses: poor rate of climb, allegedly sluggish maneuverability, size that made it an easy target for deflection shooting. The Luftwaffe's experienced pilots approached early engagements with the confidence of craftsmen facing apprentices, certain that superior tactical skill would overcome any material advantages the American fighter possessed. The reality destroyed that confidence within weeks. German pilots discovered that the Thunderbolt's supposed weaknesses were irrelevant in the hands of pilots who understood how to exploit its actual strengths. The aircraft climbed slowly at low altitudes but achieved superb performance above 20,000 feet, where most combat occurred. It turned poorly in horizontal maneuvers, but could execute vertical maneuvers that left Bf-109 struggling to follow. Most devastatingly, it could dive at speeds approaching the sound barrier, accelerating away from pursuing German fighters with such authority that interception became impossible. Luftwaffe pilots who attempted to follow Thunderbolts into high-speed dives discovered that their aircraft began to experience control surface flutter and structural stress at speeds where the P-47 remained stable and controllable. The firepower was equally shocking. 8 50-caliber machine guns synchronized to fire through the propeller arc delivered a combined rate of fire exceeding 100 rounds per second, a weight of fire that could saw a Bf-109 in half with a 2-second burst. German pilots accustomed to the precise marksmanship required with cannon and machine gun combinations found themselves facing an enemy whose weapons philosophy emphasized overwhelming volume of fire. A skilled Thunderbolt pilot didn't need pinpoint accuracy. A general hit on target was sufficient because the sheer number of rounds striking simultaneously guaranteed catastrophic damage. But the most psychologically devastating characteristic was survivability. The Thunderbolt's radial engine could absorb multiple 20mm cannon hits and continue running. German pilots reported emptying their ammunition into P-47s that simply continued flying, trailing smoke perhaps, but maintaining formation and eventually escaping to Allied territory. The aircraft's structural strength allowed it to sustain battle damage that would have caused any German fighter to disintegrate, and the self-sealing fuel tanks meant that hits that would have turned a Bf-109 into a fireball merely caused minor fuel leaks in Thunderbolts. The psychological impact was profound. How do you fight an enemy you cannot kill? The intelligence reassessment that followed the first 3 months of sustained Thunderbolt operations represented the Luftwaffe's grudging acknowledgement that American fighter doctrine had evolved beyond German comprehension and possibly beyond German counter-capability. Technical analysis teams studying gun camera footage and wreckage from downed P-47s submitted reports that read like confessions of institutional blindness. The American fighter was not an improvised design, but a carefully engineered weapon system optimized for a specific tactical role, high-altitude bomber escort, and air superiority combat in the extreme conditions of European theater operations. The engineering philosophy was fundamentally different from German design approaches, where Luftwaffe fighters emphasized agility and achieved it through lightweight construction and powerful engines. The Thunderbolt accepted weight and used brute force to overcome it. The massive R-2800 engine was essentially impossible to kill with small arms fire. Its 18 cylinders arranged in 2 rows meant that multiple cylinder failures still left sufficient power for controlled flight. The turbo supercharger system, located in the rear fuselage and connected to the engine through ducting that ran the aircraft's length, provided exceptional high-altitude performance while simultaneously creating redundancy that made single-point failures non-catastrophic. The armament installation revealed meticulous attention to reliability. The 8 50-caliber Browning machine guns were mounted in the wings with feed systems designed to function under extreme G loads and negative G conditions that would cause German guns to jam. Each gun carried over 400 rounds, giving the Thunderbolt ammunition capacity for sustained combat, rather than the brief firing opportunities that limited Bf-109 engagements. The convergence pattern was set for optimal effect at 300 yards, close enough that skilled pilots could achieve concentrated fire, far enough that engagement didn't require dangerous proximity to agile German fighters. But the most disturbing revelation came from Luftwaffe pilots' own combat reports. The Americans were learning faster than German tactical doctrines could adapt. Early Thunderbolt pilots had fought tentatively, uncertain of their aircraft's capabilities and vulnerable to experienced German pilots who exploited altitude and energy advantages. Within months, American pilots had developed tactics specifically optimized for the P-47's characteristics: maintain altitude advantage, initiate combat with high-speed diving attacks, use superior dive performance to disengage at will, and refuse to engage in turning fights where German fighters held advantages. The learning curve was visible in casualty statistics. Early exchange rates favored the Luftwaffe, but by mid-1943, Thunderbolts were destroying German fighters at ratios that approached 3 to 1. The question was whether the Luftwaffe could develop effective counter-tactics before attrition destroyed its experienced pilot cadre entirely. The psychological fractures within Luftwaffe fighter units deepened through the summer and autumn of 1943, as the cumulative weight of combat against Thunderbolt-escorted bomber formations revealed the unsustainable arithmetic of attrition warfare against an enemy with superior industrial capacity and improving tactical competence. German pilots faced an impossible tactical equation. Bomber interception was their primary mission, but executing that mission required penetrating fighter screens composed of aircraft they increasingly could not defeat in combat. The stress manifested in patterns familiar to any military force approaching the breaking point. Experienced pilots requesting transfers to less dangerous theaters, increasing rates of combat refusal disguised as mechanical problems, and deteriorating unit cohesion as casualty rates consumed the veteran corps that maintained tactical discipline and institutional knowledge. Oberleutnant Schroeder's squadron exemplified this degradation. In January 1943, the unit had fielded 18 aircraft flown by pilots averaging over 200 combat hours, men who understood Bf-109 capabilities intuitively and could execute coordinated attacks with the precision of orchestrated music. By October, the squadron operated 12 aircraft on average, flown by pilots averaging fewer than 50 combat hours, with tactics that had devolved from sophisticated coordination to individual survival instincts. The difference was written in casualty reports. Experienced pilots killed when they attempted maneuvers that required precision their less experienced wingmen couldn't maintain, or when they engaged Thunderbolts using tactics that had worked against P-38s, but proved suicidal against opponents who had learned to exploit the P-47's specific advantages. The Luftwaffe attempted to address the crisis through tactical directives that emphasized frontal attacks on bomber formations, approaches that minimized exposure to escort fighters by requiring only brief penetration of the fighter screen before engaging bombers and disengaging. The tactic worked in theory, but proved catastrophically difficult in practice. Frontal attacks required precise closure rates to avoid colliding with bombers while still achieving effective firing solutions, demanded absolute nerve to maintain course while closing at combined speeds exceeding 600 miles per hour, and left German fighters vulnerable to Thunderbolts that dove from altitude to intercept attackers during their approach runs. The casualty rates were unsustainable. German fighter units were losing 20 to 30% of engaged aircraft per major mission, losses that would have been acceptable if inflicting proportional damage on bomber formations, but increasingly the bombers were reaching their targets and returning home while Luftwaffe fighter strength degraded irreplaceably. The Americans could replace lost bombers within weeks and lost pilots within months. German replacement rates were a fraction of loss rates, creating a death spiral of declining capability. The logistical dimension of the air war revealed another American advantage that Luftwaffe planning had catastrophically underestimated: the industrial and training infrastructure supporting the 8th Air Force's fighter operations. While German fighter production struggled under Allied bombing and resource shortages, American factories were producing Thunderbolts at rates that seemed incomprehensible to Luftwaffe intelligence analysts. Over 15,000 P-47s manufactured during the war, with production rates exceeding 100 aircraft per week at peak output. The mathematical implications were brutal. For every Thunderbolt destroyed in combat, 3 more arrived in England the following month. For every experienced German pilot killed, replacement training programs produced inadequately prepared pilots who required months of combat experience to achieve competence. Months, most did not survive. The American pilot training system operated on an industrial scale that German programs could not match. Replacement pilots arrived in Europe with over 200 hours of flight time, including advanced combat training in aircraft identical to those they would fly operationally. They had practiced gunnery against towed targets until deflection shooting became instinctive, rehearsed formation flying until maintaining position required no conscious attention, and received tactical instruction from experienced combat pilots rotated home specifically to transfer knowledge to new generations. The system created a force multiplication effect that transcended mere numerical advantage. American fighter squadrons maintained institutional knowledge and tactical competence, even as individual pilots rotated through combat tours. The logistical support infrastructure was equally sophisticated. Maintenance depots in England could rebuild battle-damaged Thunderbolts to factory-fresh condition, replacing engines, wings, and control surfaces with industrial efficiency. Spare parts arrived in quantities that eliminated the scavenging and improvisation that characterized Luftwaffe maintenance operations. Ammunition and fuel were available in such abundance that training flights could include live fire exercises, allowing pilots to maintain proficiency rather than conserving resources for combat missions only. The Luftwaffe attempted to compensate through tactical innovation and new aircraft development, but innovation required time and resources that attrition warfare was consuming faster than planning staffs could generate. New fighter variants like the FW-190D and BF-109K offered improved performance, but their advantages were marginal compared to the systematic improvements in American pilot quality and tactical doctrine. The fundamental problem was strategic rather than tactical. Germany was fighting an industrial war with craftsman-era production capacity, facing an enemy that could absorb losses indefinitely, while inflicting irreplaceable damage on German military capability with each engagement. One Luftwaffe staff officer summarized the situation. "We are fighting individual battles brilliantly while losing the war mathematically." By winter 1943-44, the moral weight of combat against overwhelming American air power had created existential crises within Luftwaffe fighter units that transcended tactical concerns and touched upon fundamental questions about duty, survival, and the relationship between individual courage and strategic futility. Pilots faced impossible choices: obey orders to intercept bomber formations escorted by Thunderbolts and accept probability of death approaching 50% per mission, or refuse combat and face court-martial for cowardice in the face of an enemy who was systematically destroying German cities and industrial capacity. Oberleutnant Schroeder embodied this dilemma on a frozen morning in February 1944, when his squadron received orders to intercept a bomber formation approaching the Ruhr industrial region. The tactical parameters were clear: over 300 B-17s escorted by approximately 100 P-47s, flying at 25,000 feet approaching from the west. Standard intercept procedures required the squadron to climb to engagement altitude, identify gaps in the fighter screen, penetrate to the bomber formation, execute attacks, and disengage before escort fighters could coordinate pursuit. The procedures were theoretically sound. In practice, they had resulted in the squadron losing 6 aircraft in the previous 8 days. Losses that reduced effective strength to 9 operational fighters flown by pilots who understood that orders were essentially probabilistic death sentences. Schroeder had 2 options. He could refuse the mission, cite inadequate strength or mechanical problems, preserve his remaining pilots for defensive operations, where tactical conditions might be less catastrophically unfavorable. This would mean abandoning cities being bombed, failing in the defensive mission that justified the squadron's existence, and likely facing disciplinary action that could end his military career, or worse. Or he could obey orders, lead his diminished squadron against overwhelming opposition, and accept that some or all of his pilots would die in combat that could not meaningfully degrade the enemy's strategic bombing campaign. He chose duty. The squadron intercepted at 11:43 hours, climbing through thin cloud layers toward the bomber formation's condensation trails. At 24,000 feet, they encountered the Thunderbolts, not in defensive formation around the bombers, but in aggressive hunter groups ranging ahead of the bomber stream, actively seeking German interceptors. The resulting combat lasted 11 minutes. Schroeder's squadron destroyed 2 bombers at the cost of 4 fighters, with 3 pilots killed and 1 wounded. The mathematical exchange ratio was approximately favorable. The strategic impact was meaningless. 298 bombers continued to their targets and successfully bombed. The 8th Air Force replaced lost aircraft within days, and Schroeder's squadron was reduced to combat ineffectiveness that would require weeks to remedy through replacement aircraft and pilots. The German response to the Thunderbolt crisis emerged not from high command directives, but from desperate innovation by pilots who understood that survival required fundamentally reimagining how fighter combat could be prosecuted against an enemy possessing multiple overlapping advantages. The tactics that evolved through late 1943 and early 1944 represented abandonment of classical fighter doctrine in favor of approaches that would have been considered cowardice or incompetence in earlier war years: extreme altitude advantages before initiating combat, hit-and-run attacks that prioritized survival over confirmed kills, and increasing willingness to disengage from unfavorable tactical situations regardless of mission accomplishment. Simultaneously, Luftwaffe High Command accelerated development of weapon systems designed to address the fundamental problem that conventional fighter armament was proving insufficient against both heavily armed bombers and resilient escort fighters. The most promising innovation was the R-4M unguided rocket, a salvo weapon that allowed fighters to engage bomber formations from beyond the effective range of defensive machine gun fire. A single FW-190 could carry 24 rockets, launching them in ripple salvos that saturated bomber formations with explosive warheads capable of destroying aircraft with near misses. The tactic worked, but it required German fighters to approach bombers on predictable attack vectors that made them vulnerable to escort fighters diving from altitude advantage. The Thunderbolt pilots, meanwhile, were refining their own tactical evolution. They had learned that the P-47's strengths, high-altitude performance, dive speed, firepower, and survivability, could be maximized through tactics that emphasized energy management and patience. Experienced American pilots no longer chased German fighters into low-altitude turning fights where the FW-190 and Bf-109 held advantages. Instead, they maintained altitude supremacy, forced German fighters to climb to engage bombers, and executed high-speed diving attacks that exploited the Thunderbolt's superior terminal velocity and structural strength. The tactic was methodical, almost mechanical in execution but devastatingly effective. The doctrinal evolution was visible in gun camera footage and combat reports. Early 1943 footage showed Thunderbolts maneuvering aggressively in horizontal plane, attempting to outturn German fighters in classic dogfighting patterns that negated American advantages. Late 1943 footage showed radically different tactics: P-47s maintaining altitude, identifying targets below, rolling into near-vertical dives that built speed beyond German fighters' capability to follow, firing during high-speed slashing attacks, and climbing back to altitude using energy retained from the dive. German fighters that attempted to pursue found themselves struggling to climb while Thunderbolts regained altitude advantage effortlessly. The Luftwaffe was being systematically outlearned by an enemy that adapted faster than German tactical doctrine could evolve. The convergence point arrived in the spring of 1944, when parallel developments in American offensive capability and German defensive desperation created conditions for a series of aerial battles that would fundamentally redefine air superiority doctrine and demonstrate the ultimate futility of individual tactical excellence against systematic industrial and doctrinal superiority. The Americans had refined their escort tactics to a level of sophistication that integrated fighter operations with bomber stream coordination, weather reconnaissance, and intelligence analysis in ways that anticipated and nullified German defensive responses before they could develop. Thunderbolt groups now operated in layered formations, close escort elements maintaining immediate proximity to bombers, area escort groups ranging at medium distances to intercept approaching German fighters, and sweep elements flying ahead of the bomber stream to engage Luftwaffe aircraft during their climb to intercept altitude. The German defensive system, meanwhile, had evolved toward a strategy of accepting unsustainable losses in exchange for inflicting maximum damage on bomber formations, a kamikaze mentality without the formalization. Pilots understood they were unlikely to survive sustained operations but maintained commitment to defensive mission because the alternative was watching cities burn without resistance. The psychology was complex, not suicidal despair but fatalistic determination, a recognition that individual survival was improbable but collective resistance remained morally necessary. The decisive engagements occurred during Big Week in February 1944, when the 8th Air Force launched concentrated attacks against German aircraft production facilities, deliberately provoking maximum Luftwaffe response. The resulting battles saw over 1,000 American bombers and 800 escort fighters engaging German defensive forces in aerial combat that dwarfed any previous air battles in scale and intensity. The Thunderbolt groups functioned exactly as American doctrine intended, maintaining formation discipline, using altitude advantage to control engagement timing, executing coordinated attacks that overwhelmed individual German fighters with numerical superiority at point of contact. The casualty statistics revealed the death spiral. Luftwaffe fighter units lost over 450 aircraft and approximately 300 pilots during Big Week, losses representing nearly one-third of operational fighter strength in the Western theater. American losses were significant, over 250 bombers and approximately 30 fighters, but were replaced within weeks through industrial production and training pipelines that operated at scales the Luftwaffe could not match. More critically, the German losses included disproportionate numbers of experienced pilots whose tactical knowledge and institutional memory could not be replaced regardless of aircraft production rates. The air war's strategic outcome was no longer in doubt. The remaining question was how long the Luftwaffe could maintain organized resistance before attrition reduced fighter defenses to token opposition. The preparation for the final phase of the air war saw both American and German forces positioning for an endgame, whose outcome was mathematically predetermined, but still required execution through sustained combat operations. The Americans had achieved air superiority over Western Europe, not the contested airspace of early 1943, but genuine operational dominance where bomber formations operated with increasing impunity and fighter groups ranged across occupied territory, seeking aerial combat rather than merely defending against it. Thunderbolt squadrons now conducted fighter sweeps into Germany itself, strafing airfields and rail targets, demonstrating control of airspace that extended from ground level to stratospheric altitudes. The Luftwaffe's response evolved toward preservation of combat capability for defensive operations against the expected Allied invasion of France. Fighter units withdrew from aggressive interception of all bomber raids in favor of selective engagement against formations threatening critical targets, accepting that most American raids would proceed unopposed in exchange for conserving pilot strength and aircraft for the strategic defensive battle that would determine whether Germany could prevent cross-channel invasion. The withdrawal was tactically rational, but strategically devastating. It conceded air superiority over occupied territory and allowed American forces to operate with freedom that accelerated the systematic destruction of German industrial and transportation infrastructure. For individual pilots on both sides, the final months brought paradoxical experiences. American Thunderbolt pilots found themselves flying increasingly routine missions where enemy opposition was minimal or absent, combat flying that resembled training operations more than the desperate battles of 1943. The danger remained real. Ground fire, mechanical failures, and weather killed pilots with impersonal regularity, but aerial combat itself became less frequent as the Luftwaffe conserved forces. German pilots conversely experienced intensifying pressure as each mission became potentially their final flight, with deteriorating aircraft maintenance, declining fuel quality, and the psychological weight of fighting a battle already lost at strategic level. Oberleutnant Schröder, now commanding a squadron reduced to 8 operational aircraft flown by pilots averaging fewer than 20 combat hours, recognized the endgame with clarity born from survival. He wrote, "We fight now not because we believe victory possible, but because cessation means accepting defeat without resistance. The Americans own the sky. The Thunderbolts demonstrate this ownership with mechanical certainty every day. But ownership requires assertion, and assertion requires our deaths. So we die, not uselessly, but inevitably, maintaining resistance that delays, but cannot prevent the conclusion." The assessment was accurate. The final confrontation was approaching, and its outcome had already been determined by industrial mathematics and doctrinal evolution. The direct confrontation that crystallized the air war's final evolution arrived not through a single climactic battle, but through the accumulated weight of daily combat operations that demonstrated American air power's complete maturation into a systematic instrument of strategic destruction. By May 1944, Thunderbolt operations had evolved beyond escort duties into multi-role operations that combined air superiority sweeps, ground attack missions against transportation and industrial targets, and close air support for anticipated invasion operations. The P-47's versatility, initially designed as a high-altitude interceptor, but proving equally capable as a ground attack platform, allowed American forces to dominate both the vertical and horizontal dimensions of airspace over Western Europe. The final aerial engagements between Schröder's squadron and American fighter groups exemplified the asymmetry that had developed through 18 months of combat evolution. On June 4, 1944, his remaining aircraft scrambled to intercept a fighter-bomber formation attacking rail yards near his base. The tactical situation was grimly familiar. German fighters climbing to intercept altitude while American aircraft already positioned at superior altitude, possessing both energy advantage and numerical superiority. The resulting combat lasted approximately 8 minutes. Schröder's pilots destroyed one Thunderbolt The pilot successfully bailed out over Allied-held territory and was recovered, at the cost of 3 Bf-109s destroyed and 2 damaged beyond field repair capability. The most psychologically devastating aspect was the professional competence American pilots demonstrated. They were no longer the tentative newcomers of 1943, but experienced combat aviators who understood their aircraft's capabilities intuitively and executed tactics with precision that rivaled Luftwaffe veterans. They maintained formation discipline under fire, communicated concisely through radio coordination that German pilots could intercept but not disrupt, and disengaged from unfavorable tactical situations with the same ruthless calculation that Luftwaffe doctrine had once emphasized. The Americans had learned everything German pilots knew about energy management, deflection shooting, and tactical geometry, and they possessed aircraft better suited to exploit that knowledge. Schroeder survived the engagement through a combination of skill and fortune, evading a Thunderbolt that pursued him into a high-speed dive by executing a last-moment pullout that grayed his vision and stressed his aircraft to structural limits. The pursuing P-47 simply followed through the maneuver with apparent ease, only breaking off when the chase brought them low enough that German anti-aircraft fire became a threat. The message was clear. Individual German tactical excellence was no longer sufficient to overcome systematic American advantages in training, equipment, and doctrine. The apex of the Thunderbolt's psychological and tactical dominance arrived in the weeks following D-Day, when the aircraft that had established air superiority over occupied Europe demonstrated its versatility by transitioning seamlessly to ground attack operations supporting the Normandy invasion. P-47s that had escorted bombers and engaged Luftwaffe fighters now dove to treetop level, strafing German armor and artillery with the same 8.50 caliber machine guns that had destroyed fighters at altitude. The transition revealed the fundamental design philosophy that had made the Thunderbolt so effective. It was not optimized for a single mission, but robust enough to excel at multiple roles, adapting to operational requirements with mechanical reliability that allowed sustained operations under conditions that would have grounded more delicate aircraft. For Luftwaffe pilots who survived to witness this evolution, the experience provided final confirmation of what incremental defeats had already taught. The air war was lost, not through individual failures, but through systematic American superiority in industrial capacity, training infrastructure, and doctrinal adaptation. The Thunderbolt embodied this superiority. It was not necessarily the best fighter aircraft in any single performance category, but it was superlatively reliable, maintainable, and effective across the full spectrum of air combat operations. German fighters might outturn it, might climb faster at certain altitudes, might possess specific tactical advantages in narrow engagement scenarios. But the Thunderbolt won through the cumulative effect of characteristics that made it a better weapon system for sustained strategic air warfare. Pilot survivability that allowed experience to accumulate, mechanical reliability that maintained operational readiness rates, and firepower that made even glancing hits potentially lethal. The final illumination came through recognition that American air doctrine had achieved something Luftwaffe planning had considered impossible, creating a fighter force that simultaneously protected bombers, destroyed enemy fighters, and attacked ground targets without requiring specialized variants for each role. The P-47 did all three, and did them well enough to achieve operational effects that specialized German fighters could not match, despite theoretical performance advantages. The realization was simultaneously humbling and educational. The Americans had won not through superior individual aircraft, but through superior understanding of how air power functioned as a systematic instrument of strategic warfare. The roaring sound of R-2800 engines had become the acoustic signature of German defeat, mechanical thunder announcing American presence across skies that Luftwaffe veterans once dominated. The lesson was complete, written in contrails and wreckage across the European sky. The revelatory transformation transcended tactical success and touched upon fundamental truths about industrial warfare, institutional learning, and the relationship between material superiority and operational effectiveness. The Thunderbolt phenomenon demonstrated that modern air combat's decisive dimension was not individual pilot skill or aircraft performance in isolated categories, but the systematic integration of training, logistics, doctrine, and equipment into coherent operational capabilities that could be sustained across years of intensive combat. The Luftwaffe had entered the war with arguably the world's most experienced fighter pilots and excellent aircraft. advantages that proved decisive in conflicts against opponents who could not match German tactical proficiency or industrial capacity. Against an enemy that possessed both superior industrial resources and institutional systems capable of learning faster than German doctrine could adapt, those advantages proved insufficient. The moral weight of this realization was profound for pilots on both sides. German aviators had demonstrated extraordinary courage, fighting against overwhelming odds with determination that often bordered on suicidal. They had adapted tactics, developed innovative weapons, and maintained resistance when strategic logic suggested surrender. But courage and adaptation proved inadequate against an enemy that could absorb losses indefinitely, while improving tactical competence with each engagement. The Thunderbolt pilots were not inherently braver or more skilled than their German opponents. They were better supported by systems that made bravery and skill more effective through superior training, maintenance, logistics, and doctrine. For American pilots, the evolution provided validation of a different military philosophy, that systematic preparation and institutional excellence could trump individual brilliance, that reliability mattered more than maximum performance, and that sustainable operational tempo defeated unsustainable tactical virtuosity. The Thunderbolt was not the fastest fighter, not the most maneuverable, not the most heavily armed in absolute terms, but it was the most effective because it integrated adequate performance in all categories, with survivability and reliability that allowed consistent operational execution. It was the embodiment of American industrial military philosophy: build weapons that work reliably, train users thoroughly, support operations logistically, and accept that systematic competence defeats individual excellence when applied at scale. The strategic implication was clear. Modern warfare rewarded institutional capabilities over individual heroism, systematic learning over static doctrine, and industrial capacity over tactical innovation. The sky over Europe had become American, not because German pilots failed, but because American air power represented a more evolved form of military organization, one that integrated all elements of air combat into a coherent system that German forces could not match regardless of individual tactical successes. The air war over Europe continued through the final year of combat, but the fundamental dynamic established by mid-1944 never changed. American air power maintained absolute dominance through systematic application of superior resources, coordinated by doctrine that had been refined through empirical testing against the most capable opponent in the world. The Thunderbolt remained the backbone of that dominance, flying over 550,000 combat sorties in the European theater and destroying over 5,000 enemy aircraft in aerial combat, while suffering fewer than 4,000 losses to all causes, a testament to the survivability that had made it such a psychologically devastating opponent for Luftwaffe pilots, who discovered that shooting down a P-47 required more ammunition and better marksmanship than destroying any other Allied fighter. The legacy extended far beyond the specific tactical successes achieved over occupied Europe. Post-war fighter design incorporated lessons learned from the Thunderbolt's operational history, that reliability and survivability often mattered more than maximum performance, that multi-role capability provided strategic flexibility unavailable to specialized designs, and that pilot protection through robust construction and redundant systems was not merely humanitarian consideration, but operational necessity that allowed institutional knowledge to accumulate through veteran survival. The robust radial engine fighter philosophy influenced American naval aviation through the Korean War, and the emphasis on heavy armament and survivability persisted through jet-age designs like the A-10 Thunderbolt II, explicitly named to honor its predecessor's legacy. For the veterans who flew and fought against the Thunderbolt, the experience provided education that transcended aviation and touched upon deeper truths about technological warfare, institutional learning, and the relationship between individual excellence and systematic competence. Luftwaffe pilots learned that courage was insufficient without adequate support systems, that tactical brilliance could not overcome strategic resource disparities, and that the enemy who learns systematically defeats the enemy who relies on individual virtuosity. American pilots learned that superior equipment required superior training to realize its potential, that institutional knowledge mattered as much as individual skill, and that sustained operations required logistical excellence as much as tactical competence. The European sky remembers through preserved aircraft displayed in museums, through gun camera footage that captures the violence and precision of aerial combat, and through the accounts of pilots who survived to recognize that they participated in warfare's evolution towards systematic industrial application of violence. The roaring sound of R-2800 engines has faded into history, but the lessons endure wherever military forces study how institutional excellence defeats individual heroism, and how systematic preparation transforms adequate equipment into dominant weapon systems.